Okay, today's lesson is going to be on right triangles. Just as a little reminder, a right triangle is a triangle that has one right angle. Now remember that a right angle is an angle that is 90 degrees. So in the triangle I have below, this would be my right angle. We can also label the different angles within the triangle. Usually we give them letters, and we just put that letter at the corner of each vertex of the triangle. So if I label these A, B, and C as such, we could label these excuse me, as angle A, angle B, and angle C. Now, the relationship between these is, if you remember all of the sums of all three of these, angle A plus angle B, let's get another color here, plus angle C is going to equal 180 degrees. Okay, so what we're going to do is we're going to take this triangle, and we're going to try and figure out some side lengths. We're also going to try and figure out some angle measures using what are called trig functions. So let's take a look at another right triangle. That didn't work very well. Let's try and extend this out a little bit longer. Okay, you get the idea. All right, so now if I said that this angle measure was 34 degrees, actually, let's back up here. Let's just say that we called this angle theta. Theta is just another variable for an angle, like x or y. We just give it theta, though. And let's just give these some letters. Typically speaking, if I call this, that's not A. If I call this A, this B, and this C, you usually give capital letters to angles, and the sides opposite, so this would be considered lowercase c. The side opposite angle A would be lowercase a, and the side opposite B would be lowercase b. Now I need those side lengths to be able to talk about the next thing. Okay, excuse me. If you remember back in geometry, we talked about three different trig functions: sine, cosine, and tangent. And we can use these three things to calculate, say, a missing side length, A, B, or C. We could also, if we have side lengths, we could figure out angles, like theta, okay? And so the way we do that is we use a relationship between each one of these functions here. And if you remember, some people use this little mnemonic called SOHCAHTOA. And what that is the S, the C, and the T inside that mnemonic represent sine, cosine, and tangent. And so what the O and H are the representations of the different side lengths. So sine is equal to the side opposite the angle that you are looking at, divided by the hypotenuse. That's where the O and the H come into play. So sine is opposite over hypotenuse. Cosine, if you look at the two letters after the C, would be A and H. A stands for adjacent, and the H still represents hypotenuse. And tangent, the O and the A, stand for opposite over adjacent. So if we were looking at this right triangle and we had this angle theta here, that was the angle that we were looking at. We would say this: the sine of theta is equal to, well, if we're looking at this angle right here, let me get a different color here. If we're looking at this angle right there, what is the side opposite that angle? Well, let's look. The side opposite theta would be the B. So then to replace opposite, you would go B, and then you put your little fraction bar, and then you would do this, the hypotenuse side. The hypotenuse side is the diagonal side, or the C. And so the sine of theta would be equal to B over C. Now typically you would have numbers there, and so that would be a way to figure out, maybe a missing side or a missing angle. The cosine of theta, again, we're still looking at the red angle. We would do the side adjacent, because that's what cosine is adjacent divided by hypotenuse. And so the side adjacent theta would be A, right here. This side length A divided by still the hypotenuse, which would be C. Sometimes you have to use cosine because you may not have the side opposite. You may have the sides that are the hypotenuse and adjacent. So you'd have to know that you have to use tangent. And then tangent, forgot theta. Tangent of theta would be equal to the side opposite, B, divided by the adjacent side, which would be A. And this is how you would use a right triangle to figure out certain side lengths. Let's take a look at an example here. Let's say I have a right triangle. Let's see if I can draw this better this time. Let's say I have a right triangle, and I know that the angle of this is, let's just go 20 degrees. I know that this side length is 8, and I want to know, what is the hypotenuse? Okay, so we're looking at this angle right here. So what is the relationship of the two things that I know? Well, with this angle, this is the side opposite, so we're going to put an O here, and this is the hypotenuse, H. So if you remember in SOHCAHTOA, the side opposite and hypotenuse, we would have to use the sine function. So we would say the sine of 20, the angle that we are considering, the sine of 20 is equal to the side opposite, 8, divided by the hypotenuse, H. Well, now that we have one unknown, that H on bottom, I can now solve this for H. And the way I would do that is I would first, I got to get H out of the denominator, so I'm dividing by H, so I would have to multiply both sides by H. On the right side of this equation, the H on top and the H on bottom would become 1. And then I have H times the sine of 20. I added that little dot there to show that is multiplication. Excuse me. And then the last thing I would do is, well, if I have H times the sine of 20, I can then just divide both sides by the sine of 20. And then if I go to my next page, I would have H is equal to, if we come back to here, that would cross out, and I would have H equal to 8 over the sine of 20. Okay, well that's great. So how the heck do I get my answer? What is 8 divided by the sine of 20? So let's take a look here. So if we use our calculator and we type in 8, then we hit our divide symbol, there is a function on the calculator that is sine. And so what it's going to do is we want to know what's the sine of 20. So we hit the sine function. It should plug in a sine here. Sometimes the calculator will put a parentheses in for you. Other times it won't. If it puts parentheses in for you, make sure you, after you plug in the angle measure that you're trying to find the sine of, you close off that parentheses like I did there. You should be able to hit equals from there, and it should give you, when I plugged it into my calculator, I got 23 point, and if you round it 2 decimal places, I get 23.39. We have just used a trig function to find the missing side of a right triangle. Now keep in mind this only works with right triangles. Okay, let's take a look at one more example quickly. Let's take another right triangle and let's label the right angle. It's usually what we do. And let's say that we have an angle of 35 degrees here. Actually, no, let's do this. Let's actually talk about this angle right here. Let's say this is angle 35 degrees. And we are going to, we know that this side length is 10, and maybe we're trying to calculate the height of something, and we want to know, what is this length over here? So let's call this just x. Okay, so again, we're looking at the angle that is 35 degrees. So what two things do we have? Do we have opposite? Do we have adjacent? Do we have the hypotenuse? We have to figure that out. So based on this angle 35, we have the side that is opposite that angle, and we also have the side that is adjacent to that angle. Remember, adjacent just means next to. All right, so in SOHCAHTOA, we have the side opposite and we have the side adjacent. So is opposite over hypotenuse, ka is adjacent over hypotenuse, but toa is opposite over adjacent. So that's the one we're going to use. We're going to use the TOA. So that means tangent. So again, we put tangent down. The tangent of our angle, 35 degrees, is equal to the side opposite, which would be 10, divided by the side that's adjacent, which is x. And then we would just use the same method to solve for x. Tangent of 35 equals 10 over x. We've got to get that x out of the denominator, so we're going to multiply both sides by x to cancel that out. So we have x, again, times the tangent of 35 is equal to, and all we have left over is 10. At this point, we can just divide both sides by tangent of 35. The tangents of 35 cross out on both sides of the the left side of the equal sign. And then I'm just going to plug x equals 10 divided by the tangent of 35 in my calculator. And when I do that, I get that the x, or that height of the triangle, is 14.28. I didn't put a measurement on here, but if we gave it inches, it'd be inches. If it was feet, it'd be feet. I never labeled this as anything, that 10 as anything, so we would just say that the length of that side is 14.28. Now, if you have any questions, you can leave it in the comments below. But I will try to answer those as quickly as I can. If you need more examples, need more things, let me know also. But that'll do it for finding missing sides of right triangles.